Good morning, everybody. Welcome to our webinar today. We are going to talk about the PureRec, our new pure recording system. But before we start, I would like to explain some organizational things. As you can see on your right side on the webinar tool, you can see a chat window. This chat is used so that you can ask us questions. Those questions will be anonymous and only me and my colleague can see these questions, nobody else. And at the end of the webinar, we will answer those questions. So feel free to ask questions. Down below, you can also see a tab for downloading some handouts. If you want, you can download directly below the chat. So let's start. Today, I'm going to be your host. My name is Thomas Goos. I'm a junior sales for Germany and Switzerland. And I'm joined by my colleague, Mr. Raphael Ludwig. Hello, Rafi.
Hi, how are you?
I'm fine, and you?
Perfect, fine.
So, Mr. Ludwig will give you a practical demonstration today about the capabilities and features of the new Purix system. It's a pleasure to have you on our show today.
Thank you.
Okay, but before we start, I would like to introduce you to the company DAVITRON, who don't know the company. So, DAVITRON worldwide, we have about 120 employees. Our headquarter is based in Graz in Austria, and we have 3 subsidiaries, one in Germany, one in the US, and one in China. We are active in 25 countries, and today we have more than 25,000 systems and quite over 400,000 channels, active channels sold. Yeah, what is our what includes our portfolio? We have mobile measurement solutions, our power analyzer, and calibrations and systems. Okay, so let's start with the PureRec. As you see, the PureRec pure recording, what does it mean? The PureRec is a reliable data acquisition system. It's portable and rugged, so you can use it in various application areas like in automotive, in wind analysis or aerospace. It includes a multi-touch display and also our analysis software Oxygen. Here on the left side, you can see the dimensions of our system. So it's quite very simple held. Some technical specifications about the PureRec. You can order it with a sample rate of 50 kilo sample per second or optional 200 kilo sample per second. It includes 16 analog inputs with a 9-pin female D-sub connector, and the voltage input range is plus minus 10 volt. And also, as I said, the multi-touch display has 15.6 inch. The weight of our system, here on the left side, you can see it's 7.3 kilogram, also very handsome. About the accuracy on the PureRec, it's plus minus 0.02% of reading, plus minus 0.01% of range, and plus minus 20 microvolt. It includes 1 terabyte SSD data storage, and the power supply is from 19 up to 264 volt AC. Optional, you can include the CAN, but I will go on in the next page. The recording features of our Oxygen, as you see, what is included on the PureRec. We have some standard software features like analysis and post-processing, visualization, math and calculation, trigger features, FFT analysis, export features, and reporting. Yeah, as I said, optional software options, that's OxygenNet. It's a distributed and synchronized data acquisition via Ethernet, where you can transfer data in remote configurations. Our CAN out, transmitting measurements via CAN, and the Ethernet receiver. It's a receiver who is receiving UDP data packets via Ethernet, so the timestamp synchronization and XML description. Yes, so far a little overview. So optional add-ons if the input ranges doesn't, if it doesn't is enough, so if you want to expand the system, we have some modular smart interfaces called MSI adapters, where you can expand the system to measure IEP, bridge, charge, temperature, voltage, and current. Okay, so now I would hand over the word to Mr. Ludwig. Oh no, sorry, I forgot something. The quasi-static channel expansion for voltage, current, and temperature. They are so-called EPAD2, so you can connect them via with a serial connector, so you don't have to use a plus minus 10 volt input. So, and now I will hand over to Mr. Ludwig, who will explain the specific details a little closer and will give you a practical demonstration. Thank you.
Yes, thank you very much. I'm just trying to share my screen with you that you can see something and follow me in what I'm doing. Okay, so thank you for the theoretical introduction into the system. Thomas, what I'm going to do now is to show you how easily and how quickly you can configure the periodic device and how easy you can how easy you can configure the system, create your setups, and how easy you can start with the measurement and also the analysis and post-processing features of the system. Therefore, I have a periodic device here next to me. The screen which is available on the device is now mirrored on my computer where the presentation is running on, so you are able to follow me configuring and operating with the system via the touch interface. And on the other hand, you have your PC, your laptop available where you see the details on the screen and what I'm doing there. So as Thomas already said, the oxygen measurement and data acquisition software is included on the system, and that's more or less the heart and the core feature of the periodic device. Just a quick introduction into the setup and to the system of the software. This is how the software is starting when you create a new setup from the beginning. And you have an overview bar up here where you see one dedicated signal, one dedicated channel, and you already see that data is already being acquired with the system. At the moment, it's just noise, but directly after the system is started, the data is queried from the hardware. Here on the lower side, you have the so-called action bar with the most important buttons to operate and to run the software. For example, here you have the start recording button, the stop recording button, and you can, for example, open a data file here or open, load, or save a setup file with these buttons here. On the upper left side and on the right side, there are the menus to set up the system, to configure your measurement, and so on. For example, you have the system settings of the device right here. You have the data channels menu to configure your hardware and your input channels, or the instruments menu is here to display and you visualize your data on the measurement screen. And the big black part here in the middle at the moment is the measurement screen where we will display and visualize our data later on. Okay, so much for the overview. When you want to create a new setup, you normally start to configure your hardware inputs. To do so, I will open now the channel list and the data channels menu to the full screen. And up here, you have a hardware overview. This is the exact mirror of your input, of your hardware inputs, which are available on the left side here, just shifted by 90 degrees. And so you can always refer to your input, to your hardware input schematics to select and to configure your input channels. And on the lower side here, there is the data channels list available with all the details of your channels included. So you see the 16 analog inputs here. The digital input and output channels are available here. And there are additionally 2 counter channels to set up encoders for rotational and angle measurement and determination, for example. But let's focus on the analog channels at the moment. What you do to configure the input. Basically, when I want to connect my signal which is now the signal of a signal generator, which is here. You select the input to which you want to connect the signal. So at the moment, for me, it's the first channel, and I'm just selecting it here in this hardware overview and make a double click to open the detailed channel setup. In the meantime, I'm connecting the signal physically to my input, and now there are all the input, the channel input options available which you need. For example, the input mode is currently voltage. That's fine when I'm using a signal generator. The range of plus minus 10 volt is fine at the moment as well. And each channel has a digital IAR filter in combination with an analog filter on board to avoid aliasing. So if you like, you can change the settings, but as long as the filter settings are set to automatic mode, you can be sure and you don't need to worry about aliasing or any other issues with your signal. And finally, here you can also include a sensor scaling to scale your measured voltage to the physical engineering unit. And that's more or less it for the quick overview. And when I'm now enabling the output of my signal generator, you instantly can see the signal here in this preview window. And so you can be sure that your signal scaled correctly, that the data acquisition is working fine with this preview window down here. Okay, so much for the direct voltage input. Thomas mentioned in his presentation that each channel is capable of acquiring directly plus minus 10 volt natively. But as we all know, there are also some other signals provided by the sensor. And if you have any other sensor which provides a different signal than a plus minus 10 volt signal, you can use so-called modular smart interfaces, the so-called abbreviated MSIs, to acquire these signals as well with your PRIG. For example, I will now show you how you can do also a temperature measurement with a thermocouple by using an MSI with the PRIG. You don't need to do any manual settings when you want to use these MSIs, but all the interface is recognized correctly and all the settings are applied automatically and no interaction by the user is needed. Sorry, my microphone's just gone. Now here it is again. And to do so, I just connect this interface now to the second channel. And you see in the hardware overview here that it is automatically recognized as THK, which is the abbreviation for thermocouple type K. And when we look in the channel list here, the input mode is automatically changing to temperature, which was voltage before, and the input range is also changing to degree centigrade. And when I'm now making double click again here on the hardware schematics, my amplifier options will open, and you see here that no additional settings are required. I am just connecting now the thermocouple here, and you see, okay, my signal is already coming in and measuring approximately 23 degrees centigrade. And you can be sure again, okay, my signal is acquired correctly and scaled correctly, so everything is working fine. Additionally, besides the temperature measurement, I would like to show you how easy you can use IEPE sensors with the system as well. Therefore, you need an MSI bridge ACC adapter, which is a dedicated MSI for supporting IEPE sensors. And I have one IEPE sensor here mounted on the top of my signal generator. So again, no manual settings are required, just connect it to now channel 3 of the system. You see here that the MSI is recognized correctly, and my input mode is automatically changing to IEPE again. I'm just entering now the channel settings again to decrease the measurement range to 1000 millivolt. And additionally, I want to include a scaling sensor, a scaling factor of my sensor. As it is an acceleration sensor, the unit is G, and the sensitivity of this dedicated sensor is 100.89 millivolt per G. When I'm now smashing, you already see the signal being acquired from the system, so you can be sure again, okay, everything is working fine and everything was set up correctly. Good. Back to the table view of the channels, I will now quickly deactivate all the channels which I'm currently not using, just by selecting all of them, deselecting the used ones and disabling the not used ones. And I will now quickly rename the used channels to signal generator, to temperature, and to ACC for acceleration. Oops, sorry. And one more word to the sample rate of the system. There exist two options of the PREG. One PREG with 50 kilosamples per second sample rate per channel, and the second one with 200 kilosamples per second sample rate for each channel. At the moment, every channel is sampled with 10 kilohertz, which you can see here in this column. 10 kilohertz sample rate is okay for the signal generator and for the acceleration signal. But for the temperature, 10,000 samples per second might be a bit much. No problem, just enter this menu here and enable the reduction option. Then you can set a specific sample rate only for this dedicated channel. And as it's a temperature, I will now use 10 Hertz sample rate for this dedicated channel. And this means now that the signal generator and the acceleration signal are sampled with 10 kilohertz, and only the temperature channel is sampled with 10 Hertz now. Okay, so much for the channel setup and for the channel list. I am now closing this menu again and return to the measurement screen, and I'm now instantly starting the recording by pressing the record button. You see that the recording mode is active by the red line on the top here and the red line down here. And now, while the recording is already running, I will now configure my measurement screen. Therefore, I am using the instruments menu and place a recorder here on the measurement screen, adjust the size a little bit, and now I assign the signal of my signal generator to visualize it in the time domain. I will now do the same thing for the temperature. Use drag and drop the recorder here, adjust the size, and then go back to the channel list and assign the temperature. As the y-axis is now scaled pretty wide, I will now go into the properties and change the scaling from 0 degrees centigrade to 50 degrees centigrade, 50 degrees centigrade. And now you see the time-dependent trend as well. As I'm also interested in the absolute value, I am now selecting a digital meter here from the list, assign the channel again, and there I have the absolute instantaneous value here. And I'm now just changing the precision to 1 decimal. Okay, so quick and easy for the signal generator and the temperature. And I am now just creating a new and blank page for my acceleration signal. Therefore, you might imagine I will also display it in the time domain, drag and drop the recorder here, adjust the size, and go back to the channel list, select it here, and there is my signal. And I will now just change the y-axis scaling to an automatic scaling of the current minimum and maximum. And here is my signal. I'm also interested in the RMS value of the signal. Therefore, I'm taking a digital meter again to the measurement screen, assign the signal, and I quickly go to the instrument properties here and change the display value from actual to RMS. So the RMS value is calculated for a block size of 0.5 seconds now. And last but not least, I'm also interested into the spectral characteristic of the signal. Therefore, I am using now a spectrum analyzer, drag and drop it here from the channel list. And I am now using assigning the acceleration signal again. And the typical FFT properties are available here in the properties of the spectrum analyzer. I will now just change the line resolution to 2 Hertz and use a decibel spectrum instead of the normal amplitude spectrum. And I also want to have a frequency, a logarithmic frequency axis from 20 Hertz to 5 kilohertz. And now you have a quickly set up a FFT analysis for your measurement signal. So much for the configuration of the measurement screen. One very useful and frequently used feature of Oxygen is the so-called déjà vu function, which enables you to start your data analysis while the recording is still running. Normally, when you use a measurement device and you want to analyze your data, you have to stop the recording, open the data file, and then you can start with the data review and with the data analysis. But Oxygen enables you to do this while the recording is still running. I will quickly show you how this is working. You can see here in the overview bar the acceleration signal from the beginning to the actual position of the measurement. And here in the very beginning, there were some smashes, which I now want to analyze while the recording is still running. To do so, I'm just grabbing the recorder and moving it to the right and start to scroll through my measurement data. And the actual position here is denoted and is denoted with this orange box here on the top. And I will now just move this orange box to the position where the smashes happened. And here they are in the recorder. I'm zooming in a little bit more with my fingers here to see, for example, this smash here exactly. I can also now increase the size of the recorder a little bit. And now I'm using some cursors, which are available here down, to measure the duration. Oops, sorry. Oh, I'm sorry. This was now my fault. I'm going back here to the smash again. I occasionally zoomed out. So now I can see the duration of my smash, for example, with a delta value here. And I'm also interested in the maximum value here and also in the RMS value of the smash. And so I can also instantly start to review and to analyze my data. And when I also want to include my data into a report while the measurement is still running, just go to the screens menu here, press the copy to clipboard, and now my recorder image is copied to clipboard, and you could include it now into any other software from the clipboard, for example, into Paint, and you have the screenshot or the picture, the image of your recorder directly created. And all this was done while the recording in Oxygen is still running. Back to the software, to Oxygen itself. And when you're finished with the recording, just press this button here with the two arrows, and then you jump automatically to the actual measurement position. And I zoom out a little bit again. And when I'm smashing here again, you see the actual position and the actual data. When your recording is stopped, just press the stop button. The data file is closed automatically, the recording is stopped, and all the data is stored automatically, so you don't have to acknowledge again, yes, I really want to store the data. This is done automatically. And for opening the data file, just go to this folder button, select the certain data file here, and press open, and then your data will be loaded for further post-processing. The first thing which I want to show you what you can for sure do is export the data into any other data format for post-processing. Therefore, we have this export menu available here with a wide range of different data formats for export, for example, CSV, Excel, MATLAB, and so on. For the sake of easiness, I will now just select the TXT file, and you can now select either all channels or just some dedicated channels for export. And I want to now only select the acceleration signal for export. And you could now either select the data for export the data from measurement start to measurement end, or again use the recorder to zoom into some specific area of the measurement, for example here where I have the smashes available. And now this export active recorder region option is automatically selected, and this means that only the time which can be seen in the recorder will now be exported when I'm pressing down here the export button. And now I just have to select the correct directory for exporting the data, and that's it. My data is now exported and available here in the dedicated directory. And here is my exported data. So quickly and easy. And a quick overview of the export features of the Oxygen software. Furthermore, you have many post-processing options and features directly available in the software. Therefore, I will open the channel list again and press here on the plus button on the lower left side to open my math menu. I will now create a formula by clicking the add button, and these formulas allow you to make basic mathematical operations with your measurement signals. For example, I will now select the signal generator signal and multiply it with the acceleration signal, for example. No matter if this makes sense or not now, but I could use mathematical operations. The basic mathematical operations are available here. And for example, the absolute value, the logarithmic value, or the root can be, the square root can be automatically calculated as well. On the next page, I have some trigonometric functions available, or some logical operators are included as well. I have some measurement functions, for example, to determine the time difference between two occurring events and channels, or to determine the duty cycle of a special or certain signal. And I also have some certain variables available, for example, to determine the measurement time or the number of samples which have been received by the software. And this formula channel is now available in the channel list here as well. And this formula is stored with the same behavior as an analog channel, so you can store this channel, you can visualize it, export it, and also compare it with other data. Additionally, when I am selecting a certain channel before pressing the plus button, I can also do some statistical calculations. For example, I'm interested now in the RMS value of my signal with a window size of 0.2 seconds, for example. Just enter it, press the add button, and here is my statistics calculation available with a couple of clicks. Additionally, I can use filters which are directly integrated. Low pass filters, high pass filters, band pass, and band stop filters are directly included, and you can also differentiate or integrate your signal. And now I want to just low pass low pass filter my signal. Therefore, I select the low pass filter and 1000 Hertz cutoff frequency. Just press the add button, and there is my filter channel again. And you can now compare the signal with your original signal. And also for sure apply and change the settings by pressing onto the gear button. You can enter the settings again and change them afterwards as well. And last but not least, it is also possible to do a math FFT. Just again, select the signal, press the plus button, go to FFT, and there are all the characteristics and the properties for the FFT determination. Press the add button, and your complex spectrum and your amplitude spectrum is automatically and instantaneously calculated. So much for the post-processing features of the Oxygen software. And the last thing and the last feature I would like to show you is the so-called reporting feature, which is available here on the left side and allows you and enables you to create PDF reports directly with your measurement software without exporting the data before. And there, for example, I would like to show you how this is working, and I'm interested in this mesh here right now, and I'm selecting the orange cursor here, place it on this mesh to see as well the frequency characteristics, the spectral characteristics of the signal here. And now I'm pressing this copy button here, and now my measurement screen is copied to a PDF page, and this can now be exported. Additionally, I go back to the measurement screens, and I also want to export to my data this area here where the temperature was increasing. I'm zooming in a little bit, select my orange cursor again, and I see the peak here was approximately 34 degrees centigrade. And now I'm going to the reporting menu again, press the copy paste button, and here is my data included on this reporting page. The design mode is accessible as well here, so you can still modify the page. So I'm now deleting the signal generator channel from the page, and I'm now changing the size of the recorder a little bit. Put this one down here, increase the size a little bit, and also the recorder size if I'm getting it, can be decreased a little bit. I'm sorry, therefore I have to use the mouse now because this is a bit small. And here we are. Okay, when you're finished, just deactivate the design mode again, and the first page is now blank. I will just delete this one. And to export your PDF report, just press the PDF button down here, or you could also send it directly to a printer if one is installed on your system. And that's it to create your PDF report, and there the report is automatically exported into my measurement directory. And here we are and have our measurement data quickly and easily reported without using any other software for the report generation. And when you're finished with the data review and with the analysis, you want to start a new measurement, just press this eject button. The software will be set into data acquisition mode automatically again. And when the data file is loaded, the last one, you can start with your measurements again and create a new data file and measurement campaign. So much as a quick introduction into the capabilities of the system. I hope you received a quick and a general overview of the PUREC device and how easily and how quickly you can operate and interact with the software with Oxygen running on the PUREC. So, Thomas, are you still there?
Yes, I'm still
Yes,
here.
there he is. Perfect.
Yeah, thank you very much, Rafi.
You're welcome.
I hope it gave a little overview about the system for all of you. So I mentioned that there are no questions, but I know something, Rafi, because you told me you have a little sneak peek today from our R&D. So would you tell
Yeah,
us what it is?
yeah, sure. As we mentioned several times now, you can expand your system with MSIs, with MSI adapters, to use more or less any sensor with the system and to acquire more or less every signal, no matter if it's a current, if it's a strain gauge signal or IAPE, or signal from an IAPE sensor. What our development, our hardware development is currently working on is this so-called MSI2 V600. This is an MSI adapter which enables you to use the PUREC also for high voltage applications. So your input of plus minus, your direct signal input of plus minus 10 volt of the system can be expanded to 600 volt RMS by using this MSI adapter. So the specifications currently are 600 volt RMS or 1000 volt peak to peak value or 1000 volt peak value. And then you can also use your PUREC for high voltage applications by using this MSI adapter. And this is one of the first prototypes which have just been developed by our hardware R&D department.
All right. Good. Yeah, then I would say thank you for listening. When there are no other questions, if there are other questions or further questions, please feel free to contact me or my colleague, Mr. Rafael Ludwig. Our contact data are available on our homepage where you have been registered or on some social media platforms like LinkedIn or so on. If you know some colleagues or other people who would be interested in the webinar, we will go live with a new topic on Tuesday, the 24th of November. And at the end of the week, we will put this webinar as a video on YouTube available for everybody. So if you know somebody who could be interested to see this video at the end of the week, it will be on YouTube on our profile. DAVITRON, if you insert DAVITRON in the search line, you will get to our profile. Okay, then I would say thank you everybody for watching and hope to see you on 24th with the new topic. Bye bye.
Thank you also from my side. Bye bye. Have a great day.